Welcome back, students. So in this session we are going to solve problems on Vogel's approximation method, whereas in previous section we have understood the algorithm of Vogel's approximation method. So now we are going to solve the problems on Vogel's approximation method. Right? So the first example, that is example 01. Find the initial basic feasible solution. Initial basic feasible solution for the following transportation problem. By Vogel's approximation method. Fine, this is what, and this question is appeared in 2018 KUD exams. Fine, so this is the data. So let me write destinations. Fine, the destinations are D1, D2, D3, followed by D4, and supply. Then these are the origins: O, R, I, G, I, N as origins, that is O1, O2 and O3. Fine. Then here it is demand. This is how it is given in examination. Fine. So it is 11, 13, 17, 14, 16, 18, 14, 10, 21, 24, 13 and 10. The supply and demand are 250, 300, next 400, next 200, 225, 275, 250, it is 950. This is how it is exactly given in the examination. Fine. Fine. This is how it is exactly given in the examination. And we have to solve it by using Vogel's approximation method. Right? Solution: since total supply is equal to total demand, therefore transportation problem is balanced, that is summation AI is equal to summation Bj is equal to 950. Hence, there exists initial basic feasible solution. Fine. So as the supply and demand both are equal, then the summation AI is equal to summation Bj, then we can say the transportation problem is balanced. So there exists an initial basic feasible solution. Fine. So what we do first, we find row and column penalty, that is P1 as the difference between smallest and next smallest cost in the cost matrix. Fine. The maximum penalty is 5. The maximum penalty is 5. Fine. So how? The maximum penalty is 5. How it is 5? So let me draw the diagram here. So let me write here. First let me finish the writing work here. 5. Fine. For first column. Fine. So choose the first column arbitrarily. In this column, choose the cell having least cost name, that is 1,1. Fine. So which is the least cost in this column. So this is what the least cost, and its location is 1,1. Allocate this cell with minimum magnitude. That is minimum of 250, 200. Here it is 250, comma 200 because of this is what the minimum. Fine. 200. This will make first column to exhaust. Delete this column. So I have said, let me finish the writing work here, then we will solve the problem. Fine. Since column D1 deleted, then there is a change in row penalty. So in algorithm, in the note section we have studied, so if a column is deleted, there will be change in row penalty. If a row is deleted, then there will be change in the column penalty. And same. Fine. And the last is continuing in this manner, we get remaining allocations as given in tables below. Fine, my writing work is finished now. Now let us start the actual solution of the problem. The reason is that the writing is very important to understand the problem. If I directly solve the problem, what happens here? It takes 2 to 3 to 4 or 5 examples to understand. But the writing makes you to understand better. These steps will make you to understand the better. So what I have written here, I have written the algorithm only, the steps of the algorithm only. Fine. So what we do in the first allocation? In the first allocation, it is what? D1, D2, D3, D4. So it is supply and it is P1. Here it is O1, O2, O3. It is demand and it is here also it is P1. So let me draw the tables here. Fine. So let me write the values here. It is 11, 13, 17, 14. It is 250. It is 16, 18, 14. 10, then followed by 21, 24, 13, 10, and the supply is 250, 300, 400, and the demand is 200, 225, 275, and it is 250. Total is 950. Fine. So what it is written here, first we find the row and column penalty. Fine, as P1, the difference between the smallest and the next smallest. So in P1, that is in first row and first column, we find the difference between the smallest and the next smallest. So here in this 11 is the smallest and 13 is the next smallest. So 13 minus 11, the answer is 2 here. Whereas in this respective column, 11 is the smallest and the next smallest is 16. So 16. So 16 minus 11 is 5. In the same way, so which is the smallest? 10 is the smallest and the next smallest is 14. So 14 minus 10 is 4 here. Whereas here in the next column, which is the smallest? 13 is the smallest and the next smallest is 18. So 18 minus 13 is again 5. So coming to this third row here, which is the smallest? So 10 is the smallest and the next smallest is what? Find 13. So the difference is 3. Whereas for this column, 13 is the smallest and the next smallest is 14. So it is 1 here. Fine. So coming here, the smallest is in the third row, smallest is already done. Whereas for the fourth column, smallest is 10 and the next smallest is also 10. The difference is 0. Fine. So we have got the penalties for the P1 and for the P2. For the first location, we got the penalties. P1 and P2. P1 is for the columns, rows, and this is for columns. This is the penalty. So first we choose the first column here. So maximum penalty is 5 for the first column. So choose the first column arbitrarily. So I have chosen the first column because the maximum penalty comparison is 5 is the largest. So two columns are having the same largest penalty. So I will choose the first one. I mean to say the maximum penalty 5. If any penalty is greater than 5, I have chosen the rows. So 5 is the maximum penalty. So in this column, choose the cell having the least. So which is the least in this column? That is 11 is having the least penalty. I have chosen this and check the magnitude. Magnitude is 250 and it is 200. So what I do here? So I do subtract. That is, it becomes 0. Now it becomes 15. So this particular column is exhausted. Fine, because it is 0 now. So what I do here? I remove this. So this column is deleted. Since column D1 is deleted, then there is a change in the row penalty. So it has become 50 now. So P1, in the P2 column, in the P2 row, the penalty changes, whereas P2 remains, column remains same. Fine, continuing this. So go for the second allocation here. In the second allocation, again, so I will take only D2, D3 and D4 because D1 is deleted, whereas O1, O2, O3 will remain same. Here is supply and here it is P2. Fine. Fine. So let me write the values here. Here it is remaining 13, 17, 14, and it is 50. Fine. So it is 18, 14, and 10. Remaining is 300 as it is. So the next one is 21, 24. No, not 21. It is 24, 13, 10. 24, 13, 10. Followed by 400 here. So demand is 225 here. Fine. 275. And it is 250. Fine. So we have to choose again the same. Here 13 is the, here what it is 13. So 13 is the least. Fine. 13 is the least, and the next least is what? 14. It is 1 here. Next, by the column, 13 is the least and 18 is the what? Next least. Subtracting this, I get 5. Going for the next row, it is 10 and it is 4. So I will find right 4. 10 is the least smallest element, and the next smallest element is 14. So 14 minus 10 is 4 here, whereas here 13 is the least and the next least is 14. Subtraction, I get 1. Whereas for the last row, 24, 13 and 10, 10 is the least and the next least is 13. So it is 3. Fine. Whereas for the column, both are same. Let me write 0 here. Fine. So what I do here, so I find the maximum penalty. This is again the maximum penalty. Then I will choose the least, that is 13. Fine. So what happens here? 225 minus 50, it becomes 175, whereas this will be 0. Fine. So what I do here, I have allocated 200. So I have allocated 50 here. So this will get exhausted. So let me complete the table here. Fine. So this will get exhausted. Fine. So what happens here? We go for the third allocation. So in second allocation, D2, D3, D4, and it is supply and it is P3. Fine. So in second allocation, we have deleted O1, so remaining is O2 and O3. Then it is demand. Fine. Then it is P3. Fine. Then what happens here? 18, 14, 10, supply is 300, whereas it is 24, 13, again 10, so it is 400. So here the demand is 175, 275, and it is 250. So again we choose smallest and the next smallest and find the difference. That is 10 minus 14 is 4 here. Fine. Here 18 minus 24 is nothing but difference is 6, whereas difference is 1 here. Here the difference is 3. So the largest difference is 6. So this column is selected. So I will select this because this is the minimum one. So we will get the magnitude of these two. So what happens here? This becomes 0. I will write 175. So 300 minus 175 will give you 125. So now this column is exhausted. Fine. So we will go for the next allocation, that is allocation. We will go for next allocation. Fine. So it is fourth allocation. So now it is D3, D4 supply and P4, and it is O2, O3 demand, P4. Fine. So kindly draw the tables very neat. Fine. So this will help you to understand the problem in a more convenient way. Fine. So let me write 14 it is, 10 it is 125 followed by it is 13 again 10 followed by 400, and the respective demand is 275 and it is 250. Fine. Again find the smallest, and the difference between smallest and the next smallest is 4. Next one is 3 here. Here it is 1. Here it is 0. So the largest is 4. So I will choose this column. So it becomes 125 here. Here 125. Fine. So 275 minus 125. Sorry, there is a small confusion. It is 275 only. So 4 is the largest. Fine. So here is the smallest element. So let me write 125 here. Fine. So 125 subtraction, this gives you 0 and this gives you 125. So this O2 row is exhausted. Fine. Go for the last allocation. So let me rub this theory part here. Go for the last allocation. Fine. That is fifth allocation. So we are left with D3, D4 supply and P5. We are left with only one row called as O3, then demand, then P5. Fine. So let me write the values here. 14, 10. Remaining is how much? 125. So the demand is how much here? The demand is how much here? Sorry, D3, D4 I have written, I think exactly correct. No, 13, 10 here it is. We left with only 13 and 10, and demand is 400 here. This table 400. It is 275 plus here it is 125. So the difference is 3 here. Fine. The difference is 3 here. So there is no difference here. So let me choose the largest here. So this becomes what? this becomes lot. It is 125 here. So this becomes 0. It is 275 here. Fine. This is 0. So this column will get exhausted. Which column? This column get exhausted. And we go for the sixth allocation, where we are with one column, one row. That is B3, supply, P6. Then we left with O3, demand, P6. So we left with 13 only. Here it is 275. Here also it is 275. Fine. So 275 I will write. This is also 0. This is also 0. Fine. So the complete table one by one got exhausted. Got exhausted. So what happens here? Let me write the values here. It is 200 here, followed by 50 here. So let me write 200 here, the first allocation. Then next 50 here. Then next D2, it is how much? 175. It is 175. Next followed by how much it is? Find 125. It is 125. Then followed by it is 275. It is followed by 125. Here also it is 125. Fine. Just 125 here, 125 from here. Final is 275 from this. So let me repeat this one. 200 is the first allocation. 50 is the second allocation. Next one is 175. Then next one is 125. Then next one is 125. Next one is 275. So all the allocations are done. Fine. So there are six positive independent allocations which is equal to m plus n minus 1, that is 3 plus 4 minus 1. This ensures the solution is non-degenerate. Is what? Non-degenerate, feasible, solution. What type of solution it is? Non-degenerate, basic, feasible solution. Fine. So, therefore, transportation cost by Vam is equal to, what is it is? 200 into 11. Here it is. 200 into 11 plus 50 into 13 plus 175 into 18 plus 125 into 10 plus 275 into 13 plus 125 into 10. Fine. So the total cost is rupees 1207 for you. That is 12,075. This is by Vogel's approximation method. But one thing I want to tell you students, at first problem we understand it 50%. And as we solve more problems, we are going to get expertise in Vogel's approximation method. Fine? Thank you.